bat has been considered one of nature's most mysterious animals, a creature that few of us have observed closely. Bats are the world's only true flying mammals. Some scientists believe that bats are descendants of a small tree-dwelling animal that was able to glide through the air by stretching out long folds of skin between its front and rear legs. Gradually, the bat's front legs and those folds of skin evolved into wings. Its skeleton is similar to other mammals. It has hands with fingers and toes on its feet. Bats differ in size and appearance depending on their species. Some bats are quite large, with a wingspan of almost 5 feet and a body about the size of a pigeon. Others are as small as a bumblebee and weigh only about 1/4 of an ounce. Most bats have small, sharp teeth. They chew their food up very fine and digest it quickly. This helps them avoid carrying extra weight while in flight. There are over 900 species of bats. Most of them live in caves and hang upside down, clinging to the rocks with the claws on their feet. When they want to fly, they let go and free fall as much as 15 feet in order to gain airspeed before spreading their wings and flying away. Bats live and hunt in various locations, and they're often named for their appearance. The long-eared bat eats moths that it finds clinging to leaves and on the walls of buildings. It hears the fluttering of their wings with its giant ears. The horseshoe bat has a nose shaped like a horseshoe. It mainly eats flying insects that it finds near trees and other plants. It lives in the milder areas of Europe, and it's also called the Old World bat. After it catches a moth, it uses its wings as hands and scoops the prey into its mouth. The round-nosed bat of Sri Lanka is a large bat with a wingspan of around 19 inches. Like almost 70% of all bats, the round-nosed bat is an insectivore, which means it eats only insects. The European dwarf bat weighs about 1/4 of an ounce and is about the size of a person's thumb. As with most bats, its weak legs aren't much good for walking. It uses them mostly for clinging to overhanging rocks or other surfaces. Mustached bats live in tropical areas. Insect eaters like this one can be very beneficial to us. An individual bat may eat several thousand mosquitoes in a single night. Bats are most active at night. They find their way in the dark by listening with their ears and using a sonar process called echolocation. They emit high-frequency sounds which echo as they bounce off an object. Using these echoes, bats can form an accurate picture of the area in which they're hunting. This ability enables them to locate and catch small insects on the darkest of nights. The horseshoe bat sends its locating sound through its nose. It can emit the sound in a variety of directions. The mustached bat sends out its sounds through its mouth, which is used like a small megaphone. The sound is emitted in short bursts at a low frequency. Each species of bat makes its own kind of noises. Most of these sounds are well beyond the range of human hearing. The long-eared bat uses its own unique sounds to hunt insects. The sound waves are only 3 milliseconds long, and the frequency changes quickly from high to low. Such sounds are called frequency-modulated sound. To discover how bats use echolocation to find and capture their prey, scientists have conducted field and laboratory studies. The purpose of this experiment is to determine if a bat can distinguish between different insects by using its sonar abilities. After outfitting an insect with a light source, the scientists allow it to take off. The soft wax on its back will slow its departure. The scientists will first study how its moving wings change the sound it reflects. The flutter of the wings causes a reaction in the sound recording apparatus. When the scientist moves the microphone, the pattern of the echo changes. A bat can tell by the sound reflections if an insect is facing it or is turned away from it. But do the echoes or reflections vary from insect to insect? The scientist conducts the test in a soundproof room with a camera and a tape recorder. This horseshoe bat has been trained that every time it reacts to the echo sound of a whitefly, it receives a worm. The test now is to see if the bat can distinguish between the sound of a ladybug and that of a whitefly. 2 microphones pick up the sonar sounds sent out by the bat. The sound reflections sent back to the bat are either that of a whitefly or a ladybug. The electronically altered sounds are repeated through loudspeakers. The bat is an intelligent animal. When the echoes come from the right, it turns right, and when the sound comes from the left, it turns left. However, when the sound reflections are changed to sound like a ladybug, the bat does not respond. It takes about 1.5 years to train a bat to react like the one used in the experiment. What this test proves is that the horseshoe bat can in fact distinguish between various insects by their sound reflections. Lab tests have also revealed the way in which bats use their sonar to track insects. When bats are hunting for insects, they emit sound waves that are quite long. But as the bat closes in on its prey, the sound waves become shorter and shorter until the bat catches the insect. When the hunt is over, the sound waves again become long. The test proves that bats do use echoes to track the movement, direction, and distance of various insects. In the jungles of Jamaica, other scientists have conducted tests to see if the mustached bat hunts in the same way. The mustached bat is the most common mammal in Jamaica, inhabiting a remote northwestern portion of the island. The scientists put together specially designed camera equipment so they can photograph the bats in the wild. They set up a propeller in front of the camera to attract the bats. The rotating blades imitate insect sounds and lure the bats. After one more equipment check, the scientists can only wait. Finally, night falls on the jungle. In their cave, the bats begin to stir. Like many species of bats, the mustached bat lives in a colony that may number into the thousands, possibly the millions. The bats spend the day either sleeping, grooming their fur, or tending their young. But now, just before dark, they become restless. The moment arrives. The night hunters take off. It's a dramatic sight, one which the scientists have been eagerly anticipating. Some of the bats hover around the cave entrance, as though checking the level of light. Then hundreds upon hundreds of bats fly into the darkness. The scientists use sophisticated sound equipment to record the shrill screams which the bats send out. Once out of the cave, the bats fly through the air at 10 to 15 kilometers per hour. The bat detector alerts the photographer, signaling her to get ready. The flash goes off 6 times for every picture. From the sequence of flashes, the scientists can calculate the direction and speed of the bats. From this and other studies, the scientists have been able to learn that bats can discriminate between patterns, even at night. Like the horseshoe bat, the mustached bat hunts flying insects. They know their territory, and they're able to locate and track their prey with their unique sonar abilities. Over millions of years, bats have adapted to their environment in many fascinating ways. Without a doubt, bats are skilled hunters in the night.